Good morning, my dear students. My name is Neil Toyna and I'm currently involved in the Hamlet Tuition Center, Brahmatol, Kathmandu and Kumudini Kunja Secondary School, Kalimati, Kathmandu. Today we are going to discuss on work, energy and power, the fourth lesson of grade 9, work, energy and power. Take out your copy and pen, put it in front of you and start taking notes whenever you need to. And always remember, you can always pause the video, or if you do not understand, you can always rewind the video as well. Okay, so let's get started from work. What is work? Okay, we will start from here. What is work? You all know that work, the term work is very familiar to you, but how to define it in the terms of mechanics or in terms of physics? Okay, in physics, how do you define work? Well, to define work, you need to think about two criteria. Okay, to define work, you need to think about two criteria. Number one is force does make any displacement. That means does the object or not? Well, these two are the criteria of work. Okay, these two are the criteria of work. So to define whether work is happening or not, whether work is being done or not, you need to ask these two questions. Okay, first one is force applied, and second one, does the object make any displacement? If your answer obviously work is being done. Okay, look at the first example here. Here you can see a person is pulling a cart. Yes, is he doing any work or not? To find out, you need to ask these two questions. Is the person applying force? Yes, he's applying force to pull the cart. Yes, and the second question, does the object make any displacement? By pulling the cart, by applying force, the cart moves in forward direction, that is in the direction of force. So the answer to the second question is also yes. That is why this person is doing work on the cart. Okay, remember? Well, this person is doing work on the cart because the person is applying force in this direction, forward direction. Yes, force is applied in this direction, and the cart is also moving in the same direction. Cart move in the same direction. See, the person is applying certain amount of force on the cart, and the cart is also moving in the same direction, in the direction of force. That means the object makes displacement. Okay, that's why he is doing work. Work is being done in this first example. But look at the second example. The person, the security guard, is standing. The security guard is standing. Okay, so is he doing any work or not? To find out, once again you need to ask the same question. Is he applying any force? Yes, of course he is applying force. Okay, otherwise how can he stand? Isn't it? He would collapse right there. He's applying force. Yes. And does he make any displacement? Well, does he move? No, definitely not. He is not moving. He is not making any displacement. Although he is applying force, but he is not making any displacement. So the answer to the first question is yes, and the answer to the second question is no. No. So is he doing any work? No, he is not doing any work. Okay, he is not doing work, at least in terms of physics. Okay, so now don't say something like, sir, I have a security guard at my home. Since he is not doing according to physics, why should I pay him? Don't say something like that. Okay, that's so absurd. Okay, now let's go to next section. We need to define work. Yes, how would you define work? Now, as I told you, to define work, you force. Displacement means cover some distance in of force. If those two criteria are fulfilled, then you can say work is done. Okay, work is done. You can say work is done when force is applied, okay, and the object makes some displacement. Done, force and displacement. So we will define work in terms of these two criteria. Okay, is to done being body, the covers distance in the direction of force. Okay, look here, work is said to be done when the force is being applied. Remember this point, force is being applied. Okay, let's make it bold and underline. Okay, work is said to be done when force is being applied on a body and the object covers some distance in the direction of force. Okay, let's make it bold this as well. Okay, so remember these 2 points. Definition of force will not be difficult at all. You can make your own definition. Okay, what is work? Work is said to be done when force is being applied on a body and the object covers some distance in the direction of force. Okay, let's continue. So physically, mathematically, force equals to work equals to force to displacement. Okay, now that is F in it of, you don't know, we are not taking an into, and you can say work is honor of a scientist. Okay, and I forgot. Okay, Joule was a surname of a scientist. Okay, the unit of work is termed as joule. So 1 joule equals to 1. How do you define joule work? And your answer would be, okay, what's happening is when Newton of force is applied on a body, one distance in the direction of force said to be. Don't be confused, this is not the end of the class. Don't panic. Okay, instead I should say don't be too much happy. We just finished one section. Okay, not the whole lesson. Okay, is work. Number 2, what is SI unit of work? Number 4, what is mathematical relationship of work? And number 5, how do you define joule work? Okay, these 5 questions are related to the first segment. Okay, work. Now pause the screen, take the questions and take the notes if you need any. We're going to next session. Okay, next session is types of work. Okay, types of work. What are the types of work? Okay, I'm going to give you 2 examples here also. Let us say that I have 2 objects. Yes, okay, this is object A and this is object B. We are going to talk about types of work. These are 2 boxes, box A and box B. In case of box A, I'm pulling this in this direction. Okay, horizontally, I'm pulling it horizontally on the ground, and the box B, I am pulling it upward. Okay, I'm pulling it upward. Yes, now what are the types of work same for both of these? Now definitely no. In the first case, In the first case, we are applying force. We are applying force against friction. Against what? Friction. Why am I saying this? Because while we try to pull the object, friction tends to oppose us. Yes, while we try to pull this object in this direction, friction tends to oppose us, and there is certain amount of friction between the ground and the box. If you are able to apply sufficient amount of force, okay, if you are able to apply friction, only then you can pull this box forward. Yes, this is the condition. Okay, if you are able to apply force greater than friction, greater than friction, only then you will be able to apply you will be able to move the box. So friction is acting in opposite direction to your work. Okay, so in this case, to perform work you have to overcome friction. Can you see? To perform work you have to overcome friction. That's why this type of work is called done against, and its display F is equal to m into high force more than gravity, 300 Newton of force. Then can you pull the object upward? No, you cannot pull the object upward because your force is less than gravity. Okay, however, if you apply a force of exactly 400 Newton of force, then you can move the object, you can lift the object upward. See, if your force is more than gravity, only then you can move the object upward. Now what you can see that here, to do work, to perform work, okay, you are applying force definitely, but if the box is not lifted up, if the box does not cover any distance in upward direction, then there will not be any work. So to do work, the object must move upward, and to move the object upward, what you need to do? You need to overcome gravity. Yes, you need to overcome gravity. So what you are doing? You are doing against work will of mass of object, okay, due to gravity. And there are two types of work. They are, you know this, number one, okay, work done against friction, worked against gravity, and number one, work done against slide object over the surface. Okay, that means slide an object horizontally, yes, surface, opposing acts on the object that tends to resist the slide. This force is called an object overcome friction done against the example, pulling or cart. Okay, and mathematically W is F to work done when we lift and typically, okay, of the and force object pulls it, this force called to the to make must gravity done the gravity. Okay, W equals to into the H. Okay, W means work done, M means mass, G means acceleration due to gravity, and H means height. Okay. Okay, shall we go to next section. Yes, okay, let's revise what we have done. Okay, firstly you defined work. Okay, firstly define work, then you listed the factors affecting work. Well, these are the factors affecting work. Yes, okay, did I forget to mention? Okay, factors work. Okay, these are the factors affecting works. Okay, we defined work, then the factors affecting work, and mathematical, we showed the mathematical relationship, and then we defined 1 joule work. We derived the SI unit of work and we defined 1 joule work. Okay, these are the questions to attempt. And in second section, what we did, we studied the types of work. Okay, now let's go to third section of against freaking quite easily direction. Then also, and you have straightforward formula component of work, and this is called vertical component of work. And to measure total work done, in this case to measure total amount of work done, add both the work. Yes, because you have done work in both horizontal and vertical direction, you need to add horizontal work plus vertical component of work. Okay, you need to add both horizontal and vertical component of work. Now, how to find out this horizontal and vertical component of work done? Okay, so you are given a simple formula. Okay, horizontal work, it is indicated by WF. Okay, F should be the subscript. Okay, here we have WF. Okay, subscript indicated by the formula F to D theta. Okay, now how to get theta? Let me search it here. Search it in character map. Do we have theta in character? Okay, we are using Calibri font. Then let me search theta here. Do we have? Can you see theta? Can you? Okay, okay. Here it is. I guess this is not actual exactly theta, but it resembles. It looks like theta. If I cannot find theta, I can use this character as well. Don't worry, no worry. Where is theta? Okay, 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 okay. Okay, here it is. Yes. Copy, paste. Okay. Horizontal component of work is WF F into D cos theta. Yes. And then vertical work indicated by WG. Okay, where G must be the subscript. Okay, WG is F to D in D into theta. Okay, horizontal component C cos theta, vertical component is sin theta. Okay, so therefore work is equal F. WF means F into D cos theta. WG means into sin. Okay, we just took we just took equals to force into horizontal displacement. Okay, cos theta equals to base divided by hypotenuse. Okay, I guess this is it. Yes, here should not be O. Okay, hypotenuse, or theta is equals to, what is the value of base? it is S1, isn't it? Divided by what is the value of hypotenuse? It is D. Now by doing cross multiply, what you get is 1 equation, you get F into FD of WG force in is it is sine theta. Sine theta equals to P, okay, perpendicular divided by hypotenuse. Yes, or again theta P sine. The value of P, you know, it is S2, isn't it? Value of P is S2. Yes, and the value of H is D. You see, value of P, it is S2. Yes, BD is S2 means AC is also S2, and value of H is D. So by cross multiplying, you get S equals to D theta. Now substituting this value here, what you get is equals to into D sine theta. Okay, see, this is how you get WG equals F into D sine theta and WF equals F into D cos theta. Okay, now let's get back to our previous section here. Okay, section 4. Okay, here now you understand up to here. Yes, you just need this form. It is not very difficult, isn't it? Okay, ft cos theta, ft sin theta, not so much. Now you need to attempt some questions to attempt. What are the types of work? First question, differentiate between the types of work. Second question, what are the components of work when force is applied by making an inclination to the horizon? And numericals, calculate the work done when a person of 50 kg climbs a 20-meter tall tree. Okay, here you need to determine whether the work is being done against gravity or against friction. Now it says climbs, isn't it? Climbs means definitely the work is being done against gravity. And what is the formula of work done against gravity? It is W equals to mgh. Here what is the value of m is given? 50 kg. Yes, value of g, you always know this, 9.8 meter per second, and value of h is given 20 meter. Yes, okay, you can easily do this. Now the second question, a load is pulled through a slanted surface by an effort of 150 Newton. You can see this object, it is being pulled up by an effort of 100. This is the value of